Hello, today we will discuss about the design procedure of bar joint. In last lecture we have discussed how to design a weld joint using fillet. The fillet strength has been calculated and we have discussed that the size of the weld, then throat thickness of the weld, minimum size of the weld, maximum size of the weld of the fillet, that we have discussed. And today I am going to discuss about the butt weld, which we have given an introduction of the butt weld in last to last class. So, butt weld is basically a type of weld when two plates are joined at the same plane. That means, I have shown earlier, if you remember, that when two plates are joined, plates may be of different size or same size. When these two plates are joined together, this may we can make joint and groove it. This type of weld joint is called butt weld. Also, butt weld we can see that when a T joint is desired, in that case also we can use this butt weld. Now, in case of butt weld, we have certain specification. So, we need to know the specification like size of the weld, how the size of the weld will be calculated, then effective length of the weld, then effective area of the butt weld and reinforcement. So, if we see here the two plates, this is one plate and this is another plate, are connected in the same plane, and through fusion we have joined, and this is called throat thickness. This is called throat thickness, from which the size of the weld can also be found, and this extra deposit is called reinforcement. And I told this reinforcement is necessary, though we do not calculate the strength due to this extra deposit, but this is necessary for efficient joint of the members. Means to ensure the full strength, we provide certain amount of reinforcement. Now, size of the weld can be defined by the effective throat thickness as follows. Like the size of the butt weld is the thickness of thinner plate. This is one, that if we have two plates joined together, suppose if we have two plates, then the size of the thickness of the thinner plate will be the size of the butt weld. Now, in case of complete penetration, the effective throat thickness will be the size of the thinner plate. Otherwise, we have to calculate, I will come later. And different type of complete penetrated joint are there, like double V bar joint, double U bar joint, double J and double bevel bar joint. These are some example where completely penetrated. So, in this case, the thickness of the thinner plate will be the size of the weld. In case of incomplete penetration, the effective throat thickness is taken as 7/8 of the thickness, right, not the full thickness. So, 7/8 of the thickness of the thinner part, but for the purpose of stress calculation, we will calculate 5/8 of the thickness of the thinner part. So, there are two things. When we are going to calculate the effective thickness of the butt weld in case of incomplete penetration, we will calculate the effective throat thickness as thickness of the thinner plate times 7/8 times thickness of thinner plate. But when we are going to calculate the strength of the plate, we will calculate 5/8 times of the thickness of thinner plate as effective throat thickness. Now, the difference in thickness between two plates should not be more than 25%. This also we have to keep in mind, 25% of the thickness or 3 mm, whichever is more. So, difference between two plates should not be more than 25% of the thickness or 3 mm, and if difference is more than 25%, then a tapering is required of 1 in 5 has to be done. Tapering has to be done to adjust this. So, this also we have to keep in mind. Now, the effective length. Effective length is calculated in similar way as we have done in case of fillet weld. The effective length will be based on the effective area. It is the area of the butt weld for which the specified size, that means the effective throat thickness of the weld exists. That means, the length in which the effective size of the throat thickness are existing, that length will be the butt weld length, and the minimum length of the butt weld should not be more than at least it has to be more than 4 s, where s is the size of the weld. So, minimum length has to be 4 times the size of the weld, and I told, again I am repeating here, that in drawing only effective lengths are shown. The welder must provide an additional length of 2 s to get the overall depth. So, in drawing we will show the effective length, but welder has to add 2 s for designing, means for at the site it has to consider. Now, reinforcement. Reinforcement is basically an extra deposit over the plate, and this is also necessary for effective strength of the joint, and this is around, means at least 10% greater than the thickness of the weld material. So, the extra deposit of the metal above the thinner plate between 1 mm to 3 mm is not considered for stress calculation or design. The reinforcement is provided to increase the efficiency of the joint. So, reinforcement has not been taken into consideration for calculation of strength, but to make it efficient we need to calculate, we need to provide the reinforcement. And what will be the permissible stress in the butt weld? That also defined, that is, the stresses of butt weld should be taken equal to the stress of the parent metal in case of shop weld. So, stress of the butt weld will be the stress of the parent metal. Stress of the butt weld we can consider as a stress of the parent metal, but the value will be reduced to 80% when it is done in field. At the site, if we make this, then 80% reduction has to be done. Now, we will calculate the design strength of butt weld. Design strength of butt weld in tension or in compression can be found from this formula: T d w is equal to F y L w T e by gamma m w, where L w is the effective length of weld in millimeter. So, L w is the effective length of weld, and F y is the yield stress of weld and parent metal, means whichever is smaller of yield stress of weld and parent metal. This is F y, and T is the effective throat thickness in millimeter. That effective throat thickness, how to calculate, that we have discussed, that is the thickness of the thinner plate in case of complete penetration. In case of incomplete penetration, it will be 7/8 of the thickness of thinner plate, and for strength calculation it will be 5/8 of the thickness of thinner plate. Then gamma m w. Gamma m w, as we told earlier, that is a safety factor, partial safety factor for welding, and this value is taken as 1.25 for shop welding and 1.5 for site welding. So, this is the design strength T d w has been calculated as F y L w T e by gamma w, and this is design strength of butt weld in tension or compression. But in case of shear, the design strength will be divided by root 3. V d w is equal to F y L w T e by root 3 gamma w. Design strength will be this. Now, stress due to individual force. When subjected to different type of compressive or tensile force, then the stress we can calculate by the force divided by the effective area. Effective area means T E into L W. So, we can find out the stress, compressive stress or tensile stress or shear stress, that can be found from this formula, P by T E into L W. F A is the normal stress due to axial force and Q is the shear stress due to shear force, and P is the force transmitted, it may be axial force or it may be shear force, and T E is the effective throat thickness of the weld in millimeter, and L W is the effective length of weld in millimeter. So, the compressive stress or tensile stress or shear stress, means this is basically normal stress and this is shear stress. This can be calculated from this formula, that is P by T E into L W. P is the axial force or we can consider as a shear force, and T E into L W is the effective area of the weld zone, that is T E into L W. Now, combination of stresses. So, it may happen that two type of stress or more than two type of stress are acting together combinedly. So, in this case we have to find out the equivalent stress. Equivalent stress we can calculate F E as square root of F A square plus 3 Q square. When it is subjected to a combination of normal stress, normal stress means due to axial tension or compression or bending tension and compression and shear stress, then the equivalent stress can be calculated in this way. So, F E we can find out with the combination of these two, F A square plus 3 Q square, and square root of that will be the equivalent stress. F A is the normal stress due to axial compression or tension or due to bending, and also in case of bending it may be due to bending stress in tension or compression, and Q is the shear stress due to shear force, right. Now, if we go for another stress which is called bearing, combined bearing, bending and shear. So, if we combine these three stress, then the equivalent stress can be calculated from this formula. That is, if bearing stress F B R is combined with bending stress and which is maybe tensile or compression and shear stress Q under the most unfavorable condition of loading, then the equivalent stress F E can be obtained from this formula, that is F E is equal to square root of F B square plus F B R square plus F B into F B R plus 3 Q square, where F E is the equivalent stress and F B is the calculated stress due to bending F B, and F B R is the calculated stress due to bearing, and Q is the calculated stress due to shear. So, three type of stress here we have seen. One is due to bending stress, another is bearing stress and another is shear stress. If three stress are acting together, then we can use this formula for calculating the equivalent stress, that is square root of F B square plus F B R square plus F B into F B R plus 3 Q square. This is how we can find out the equivalent stress when combined bearing, bending and shear are acting together. Now, we will go through some example. We have seen how to find out the strength of the butt weld, we have seen how to find out. Now, through some example we will see how to calculate the strength of butt weld due to incomplete penetration, due to complete penetration. This also we will go through this example and we will see how the design strength is going to vary, right. Here two plates are of thickness 12 mm and 10 mm are to be joined by a groove weld, means butt weld. The joint is subject to a factor tensile force of 250 kilonewton. Assuming an effective length of 150 millimeter, check the safety of the joint for single V groove weld joint and double V groove weld joint, right. So, this is what we will calculate. So, now in first case, if we have single V groove weld joint, so in case of single V groove weld joint, we have two plates of thickness 12 mm and 10 mm. Right. So, this is 10 mm and this is 12 mm. Now, single V groove joint is done, that means it is incomplete penetration. So, it will look like this, incomplete penetration, right. So, in this case the thickness will be actually 7/8 by thickness of thinner plate, that means it will be this, but the effective throat thickness will be means calculated for calculation of the strength. So, effective throat thickness will be 5/8 of 10, that is 6.25 millimeter. So, this is the effective throat thickness. Now, effective length of the weld is given in the question, that is 150 millimeter. So, we can find out the shear strength of the weld, that is strength will be LW TE Fy by gamma MW. So, LW is 150 and 6.25 is the effective thickness and Fy is 250 by 1.25 into 10 to the minus 3. So, this is coming 187.5 kilonewton, right, and it is less than 250 kilonewton, right. So, it is okay, joint is safe because it is it is not safe. The design strength is coming 187.5 kilonewton and external force is 250 kilonewton. So, it is not safe. That means, when we are using single V groove weld, then under this condition joint is not safe. Now, let us see for double V groove weld. For double V groove weld, in second case, throat thickness will be thickness of thinner plate, that will be 10 mm. In case of this, it will be this is 10 mm and this is 12 mm. So, this is double V bar joint. So, it will be grouped like this, right, it will be grouped like this. So, it will be like this double V bar joint, right. So, strength will be strength of weld will be LW TE Fy by gamma MW. This is 150 into 10 into 250 1.25 into 10 to the minus 3. This is becoming 300 kilonewton and it is more than 250 kilonewton. That means it is safe, right, because the strength of the weld is coming 300 kilonewton and external force is the tensile force is coming 250 kilonewton. So, the strength is okay, means joint is okay. So, what we have seen here, that if we for same case if we use single V bar joint, then joint is going to fail, and if we use double V bar joint, joint is safe. Now, why? Because in case of double V groove weld, its thickness is becoming more, effective throat thickness is becoming 10 mm, the thickness of the thinner plate. But in case of single V bar joint, as incomplete penetration is there, therefore, the thickness of the effective thickness of the weld is quite less, that is 5 by 8 of 10 mm, right, that means 6.25 mm. Therefore, the force carrying capacity of that weld is becoming comparatively less, and we could see that it is going to be fail, but in this case it is not, it is safe, it is not going to fail. Now, we will go through another example. A joint, let us write down, a joint is subjected to a factor shear force. In earlier case we have considered tensile force, shear force of 300 kilonewton. Assuming, in this case we will assume single V groove weld, that means its thickness will be 5/8 of the thickness of thinner plate, right. Single V groove weld joint, find the effective length of weld if the thickness of thinner plate is 8 mm, right. Now, we can assume Fe 410 grade bolt steel plates and welds are shop weld. Right. So, this is a joint where shear force V is coming, means V will be 300 kilonewton, and here gamma MW will be basically 1.25 because of shop weld. So, gamma MW will be 1.25, and for single V group weld, it is single V group weld TE will be 5/8 of T. Here thickness of thinner plate is 8 mm. So, 5/8 of 8, that means 5 mm. So, we can find out the length of weld. Now, we know the formula for design calculation, design strength calculation of part weld for shear as VDW is equal to LW into Fy into TE by root 3 gamma MW. So, from this I can find out LW as root 3 into 1.25, sorry, root 3 into gamma MW into VDW by Fy into TE. So, VDW is basically V here, design strength has to be equal to the shear force. So, we can find out root 3 into 1.25 into 300. For making kilonewton, we will multiply with 10 to the minus 3 into 250 into 5. So, this is becoming 520 mm, right. So, the effective length of the weld will be 520 mm. Effective length of the weld LW will be 520 mm. And if effective length of the weld is 520 mm, then the total length we can find out, total length will be LW plus 2S, where S is the size of the weld, right. So, this is how we can find out the total length of the weld, right. So, in today's lecture what we have seen, that how to calculate the design strength of butt weld, and this butt weld may undergoes under, means it may be under tension or compression, means normal stress, normal forces, or under shear. So, both the cases we have calculated how to find out the design strength of the weld, and of course, here we have to remember whether it is going to be full penetration or partial penetration, incomplete penetration, and accordingly we have to find out the throat thickness or effective thickness of the weld properly, because the strength depends on the effective thickness of the weld. So, for today this is all about the butt weld. Thank you very much.